Okay, recording has started. So today we continue with the software carpentry course about this introduction to Matlab, programming with Matlab. We kind of revise quickly the part 6 and finish it because we didn't finish it, and then continue with the 7 and 8. And so we're done with this. As always, we use the HackMD. So here you can write your questions while I'm typing, or comments or things that comes to your mind, and then at the end we can chat. We try to have a break at the hour, and during the break, those who need the credit, you can basically send me a direct message on the Zoom chat with your name and surname, and I'll mark you in the credit sheet. So yeah, basically last time we kind of discussed, we check these statements, because when we program, often we need to have a program that needs to make a choice. So if is the classic statement that is basically present in any programming language, and the way Matlab wants it is that it's like a block, and a block must end with the keyword end. And so, for example, in this case, if this block is checking if the number that we are dealing right now is bigger than 100, and if that's the case, it does something. In this case, just displays. Otherwise, so the else is kind of, the other option. So basically, if this statement is not true, if this is false, then this second part of the block is executed. Well, we don't need to go. I think it was quite clear, the example that we did on the nesting of else if, etc. But one thing that we didn't really touch was a little bit about the kind of so-called Boolean logic, or true and false statements. Of course, this we don't really have time to go through Boolean logic and combination of statements, but basically what you need to know when it comes to Matlab is that if evaluates if the statement that comes after is true or false. So let me open the Matlab. I'm gonna switch to layout, maybe where I only see the command window, and maybe the editor can be undocked. And I try to use half of the screen for Matlab and half of the screen for the carpentry material, so that you can also decide which half of your screen you want to have your Matlab. So in general, let me clear the space, close all figures. Now we are fresh. I don't have anything in my workspace. So if I type true, let's say that we want to store in a variable. So I think actually one has to type it. Okay, now this is a logical. So true is actually a Matlab keyword that means logical one. So now A is a variable of class logical. And of course, if you have a previous knowledge of logic, the only value this variable can have 1 or 0. So then the opposite would be A is false. So it's the logical 0. So whenever we do this kind of statements that need to be passed to if, for example, 11 bigger than 10, the output of this statement will be a logical value. So A equals 11 bigger than 10, and now A will store a logical 1, because this is a true statement. If we would test that 11 is smaller than 10, this is not a true statement, and we get a logical 0. What is interesting, and what you will come across if you need to code more complicated kind of assert statements, is that we might need to combine things. So now I'm inventing, and then we can go back to the teaching material. I have the variable 10, or, and I just want to check if x is bigger than, and it's true, but also want to check if x is 100. Check this kind of point. So what we can do is that I want both to be true. I want x to be bigger than 0, and also that x is smaller than 100. So now this operator combines logical values. And in Boolean, if and true statement only if both sides are true. In this case, the value of x is 10, so both sides are true, and this end will return true. So now x is kind of interval between 0 and 100. And yes, it's true because x is 10. But now if we would put that the value of x is 1000, now this statement, the first part is true because it is bigger than 0, but the next part is false. So now this end will return, if this is true and there is false, the end will be false. So if we repeat the statement, yes, now it's false. So in general, this goes back to our Matlab operators page. Let's find it because it's one of those pages that I visit quite often. And in the Matlab operator, there are this logical operator. Now, what do you you notice that this AND operator, I use this double kind of ampersand, which is like a et in Latin, and which is different than the single one. And you see the same in other programming languages. So the idea here is that AND is that kind of statement that if I already know that the first one is false, I don't need to check the second one. If I already know that this beginning part is false, then there's no point for me to check the other one because false with whatever comes after will be false. And so kind of this speeds a little bit compared to this, where one kind of first needs to check both statements and then does the end. Another statement another logical combine kind of logical statement. So the difference between or is that we are happy if just previously now x is 1000, and we wanted to check if x is within the interval of 0 and 100, and it was false. But here we're just happy if x is bigger than 600. So we don't need to have both, so it's not like the and. It's just that if one is true. So, I mean, if both are true, fine, we also get a 1. But here specifically, it's enough that x is bigger than 0, which it is, and now this value will be true. And yes, it's a logical one. So what is then becomes interesting in Matlab and also in other programming languages is that while these statements are explicit, you can kind of compute yourself that x is bigger than 0. It's a true. So, it's easy to read the code and even test it mentally. Things starts to become more difficult when you need to know how the programming language tests for things. So for example, an empty string, let's check if an empty string is true. So I'm gonna select this code and paste it in the chat. So an empty string is not true. Some other programming languages, some of them are really like bad with this kind of unintuitive statements, like JavaScript is quite not intuitive with these things. In some programming language, you might have that, any string is, or there are special strings that are false and every string is true. But here, empty string is true was not displayed, so empty string is false. Let's check now a non-empty string. And yes, a non-empty string is true. So it doesn't really matter. Here we wrote full, but you can have a full paragraph. Anything that is considered there is not false. So there is something, okay, if thinks that it's a true thing. Now this is the so-called empty array, and let's check if the empty array is true. And of course, the empty array is like the null, the zero is like the empty string. Empty string is just a special case of an empty array. And the empty array is also false, so this statement is not executed. And similarly, the non-empty array, I'm expecting to be true. And yes, a non-empty array is true, so now the statement was executed. And it's the same story, we just need to have something in the array, and it, it explains true. And then of course one might wonder, yeah, but we are zeros, and zeros, although this is the number zero, can also be interpreted as a logical zero. So let's check if an array of zeros is true and not. So an array of zeros is even though these zeros are kind of not belonging to the logical class for MATLAB, they are, when the statement is evaluated, they can kind of be used also, they interpreted as logical zero. So in this case, if they're all zeros, then this is, it's a false, and this statement is not executed. And then of course the final one, the tautology, if true is true, yes, we define it. So this is a Matlab keyword. It starts to get tricky if you rename the keyword into something else, but don't do it. So that. All right, then there's a small exercise. Let's hide the solution. Sorry about that. That performs a test and displays 1 when the first variable is within 10% of the other variable, and 0 otherwise. So we don't need to do this comparator implementation with your partners. This is what we do in a more, how can I call it, in a live course, but it's a fun exercise. So I'm gonna be silent for a minute that you can start thinking about it. I recommend maybe using the editor. I could call it near.m. And then, so yeah, if you can start coding this exercise, or you can spy on the solution, then I'm going to try to code it without looking at the solution. So I'm going to try to, for a minute, we're doing this close enough exercise in this page. I can also paste the link of the page for your convenience. And try to see if you are able to code this. It's a simple script that wants to test if two variables are in 10%, or if the first variable is with the other. I can check the HackMD in the meantime to see if there's any question. There's no question. But nothing to remember to specify. The videos will be uploaded on the Aalto Scientific Computing YouTube channel. There's already the first. I want to cut it a bit because there's a black border around, but yes, that's the place. Okay, so maybe I start coding it myself. So I'll call them. Let's call it integer. I give it to 95 MB, which is 99. So I want to test that that they're within 10%. So it's basically a ratio R divided by B, and I want to check that this is kind of, if A and B are close to each other within 10%, so this should be whether it's 0.9 if A is smaller or 1.1 is A bigger if A is bigger. Then, so if A, actually the ratio is bigger than 0.9 or bigger or equal, maybe, why not? And we also need that the ratio should be lower or equal than 1.1, then we can display 1, displays a 1. Base. Right, let's check how they solved it. So here they had, well, actually they did better than, of course, I didn't. So near this script checks that the two variables A and B are 10% or within 10% of variability. And this display 1 if that's the case. Okay, so I moved the editor a bit on top of the solution so that I can press play and see what comes out. 95 and 99, they should be quite close to each other. So yes, I get them 1. I can even check the R, the array. And that's okay. If A would be a little bit bigger than 4, I think we're still that within the 10%, and yes, it works. So hopefully you were able to do this exercise. If you have strange syntax errors, they are good to. It's good. Of course, it's not good to have errors, but paste it on the HackMD so that later we can check it. And it's I'm actually surprised that even for me it worked immediately because often there's always an error. When I write a script and there's no error, I'm starting to feel like, okay, there must be something wrong that I didn't get any syntax error. But we can check it later. If you write it on the HackMD, we can check the errors later. All right, so if statements can also be combined with loops, meaning that you have learned about loops last time. So this for, that it's kind of cycles through all the values, in this case of the vector numbers. And so then, in this case, specific case, this nice bit of code would basically first define a vector that has some integers, some are negative and some are positive, and then wants to compute the total. But the total only counts the positive numbers. So that we would basically need to sum only 3 plus 2, that it's 5, plus 9 goes to 14, and plus 6 is 20, and that's the value that we get. It's so nice when you actually can test the code, with your eyes, because there's only few numbers and few lines of code, so we don't need the machine. But of course, we can also test it ourselves, especially because I want to show something that is not intuitive and it's not explained in this notation here. So I'm going to call this script, how can I call it? If and for. Hopefully nothing exists. Okay, I'm going to move the editor window on this side. So maybe I do a clear all to start fresh with my workspace. So I these numbers. Let's write the same 5, 3, and you can also, of course, code it as well. This comma is actually not needed, but practice you can also define vectors just like I'm typing. This would be fine. If you don't believe me, and if I don't believe myself, I now press run, and fact that this is a row with 6 values. Yes, they are 1, 2, 3, 4, 5, 6. But of course, the comma kind of adds readability. This is not the same in other languages where comma or other things are needed to explicitly mention that not the same element. So now we have our vectors. Then we have this total, just a number where we want to set the total. And then we combine the 4 numbers. And then if the number that we are testing is bigger or equal than 0, the value of total with the value that we have right now. We do an end. We close the if block, we close the for block, and then we can display the output. So now the round brackets are the function disp, and the square brackets will be a vector of strings. And there's 2 strings here combined, one that is explicitly written, some of values. And the second string, also here, you don't really need the comma with num2 string of the total. All right. A bit so that I can press on the play button and see what happens in the main terminal window. And yes, we got that the sum of positive values is 20. We check, for example, that this found. Now the statement, so that we'll have 2, 3, 4, because we have 4 positive values. This extra statement that I added in the code, that every time will be executed. So we will have 4 times this statement. Now I press run again. Let's see if it works like I think. Yeah. So whenever finds a positive value, we get this statement. Now, one thing that I told you last time that I personally don't like this notation because it's not clear. Like, okay, now here I know the numbers is a row, and so I know that this n will take all the elements of this row, but sometimes we don't remember if numbers is a row. So now I'm going to try something. I'm going to try to break the code a bit. So now numbers is not a row anymore, but it's a column. And sometimes it happens that we have column. So I paste it here. Now numbers. This notation, now it's going to be broken. Now it's not cycling through all the elements anymore. It would just cycle through one element. Let's see. I really don't know what to expect as an output here, but we just press play. Yes. So look what happened. Now we just changed the shape of numbers from a row vector. It became a column vector. In between here, you might have lots of other code so that you forget if number was a row or column, and then you reach this point and you don't remember anymore if numbers was a row or a column or how was the data loaded or where this number stored. And suddenly here, what basically happens is that the cycle is done only once, because the cycle works along the columns and there's just one column. So as it once, n is n bigger than 0. So this is basically doing these numbers bigger or equal to 0. So it's testing for all of them at once. And because some of them are non-zero, this is false. And so this bit will not be executed. And in the end, our total stays to 0, as we see here. So long story short, I think the best way of writing for loops in MATLAB is always to say from 1 to nth of, in this case, numbers. And I call this normally the ID. And then n equals numbers of n ID. Made a code that I don't need to remember if numbers was a row or a column vector, but it will do what it should do. It evaluates each n separately and hopefully spits the same value out, which was 20. And now I press play, and yes. So now we made a robust code because we explicitly said that this is a row and it should go from 1 to the length of the vector. And we don't need to remember if the vector is a row or a column. So sorry if I took a little extra time, but these are the kind of errors that you spend weeks and you don't understand why is my code not working, and then it's something you thought that was a vector, was a row, is a column, and things like that. All right, but let's now try to finish this part 6 so that we can have the break. So here basically maybe we don't need to code this example, but the difference between the one basically separately of the total of the positive and the total of the negative. So there, if here we had an if block, here there will be if and else, so that we have these two different sums and whatever is the value. Now, one thing about the nesting that it's good to mention, this is also in many other programming languages. So for loop be nested, and of course, things are not how can I call it? I don't know what would be the, but basically you can't, the order of the nested for cycles will matter. So let's take this code here. For simplicity, I'm gonna copy paste it into section in the nesting. All right, so let me clear a bit. Now I'm gonna, with the mouse, I'm on top of the section. I'm gonna right click and then evaluate current section. So it will just run this bit of code in this section. And so here you see the number goes from 1 to 3 and the letter kind of goes from A to B. And so the number is now set to 1, and then the letter will first do A and do B. So first we have 1A and then we have 1B. Then this block is completed, we go back to the other 4, and now we are at 2. So there's a 2, and then we append 2A and 2B, and then the 3. So what they're basically saying here with this exercise, you don't need to do the exercise alone, but basically that the order of nesting matters as it should. So if now I do another nesting where I'm swapping the top block, so now this nesting part, when I execute only now it looks quite different, even though we still display number and letter, but now we look 1A and 2A, so the letter stays fixed, and then 3A, and then 1B, 2B, and 3B, because so the numbers are kind of, the letters are slower. If you want to make sense, or the letters consecutive because they are the outer loop, outer for, and inside, whatever is inside kind of changes at every statement. Okay, so to finish this part here, we go back to our plot all script from last week. Now I move the editor here and I see if I still have it open. Yes. So what is useful about these condition statements is that they can, for example, be handy switches. A switch, the idea of a switch is that you your code that does something, machine or some condition. If a certain switch is, off, and then the something else if the same switch is on. So specifically here, last week when we wrote this plot, all this was going through all the 12 input files and generated 12 PNG images. And because images, we didn't really want to, look at 12 images coming up on the screen. And so we set, it's common practice to kind of set the visibility and do this image, without looking at them, close the window, and then later check the output for quality control or whatever. But of course, sometimes we might actually want to see the images. There's going to be many, and there will be many windows open in our screen, but they might be interesting. So now basically what we're going to add on this plot all function from last week is a switch. So we add an extra variable called plot underscore switch, that if it's set to 0, it will show the plot interactively. If it's set to 1, it doesn't show you anything, but it saves to disk. So in the case 0, we don't need to save to disk because we want to look at the plots interactively. In the case 1, it's what we had before. All right, so this is a bit tricky because I could just copy paste this and I would be happy. But to kind of understand the changes, I'm typing with you to kind of modify the original script, plot all, so that it will become this more advanced plot all with the switch. So first thing first, read that I'm adding the comment. The script has a feature of interactive display the images or storing them on disk. Switch equals to 0. Show plots interactively. We're basically extending the help of our script so that whoever will find it, even your future sounds in the future, know what was going on with the switch. All right, so then we want to basically define the switch here. Now I want to keep the switch off, so no need to write to disk. I want to explore the images. Then I list all the files, load the files. Okay, everything doesn't need to be changed, but here, of course, because now I'm in the interactive case, I want to check, I want to add this if plot switch. I do it differently so that it's a little bit of extra man for you, but you realize that it's the same. So if the plot switch equals to 0, then we actually want to see the figures. So figure visible on. I can say here that this is the same as just writing figure. Or then if we are in the other case, the plot underscore switch will be equal to 1. It's the one that we used to add. Okay. Look that I didn't do it exactly, just to add this extra cognitive effort on your side so that you understand what's going on. It's rather than just copy pasting. Then the plotting part stays the same. We don't really need to change it, but of course at the end, when it's about saving, we need to save only if the switch is 1. So if the plot switch is equal to 1, then we need to save and close, and then the block is done. Okay, so now I save my code. I'm going to move the editor window on the side so that I don't think there's any actual statement on the maybe I could add here a statement just for clarity. Disp interactive plot on. Okay, now I'm gonna press run, so it will go 12 times. I will see this interactive plot on, and there should be 12 figures coming up in the screen. I'm not expecting to work it on the first time, but let's see. Okay, 20 there. All right, and now all the figures are on the screen, hopefully the zoom bandwidth. So now this is what I meant earlier. Now we have 12 figures all on top of each other. It starts to get messy, and these are just 12. Imagine that if you had to plot 100 figures, it's not really the best way of checking things. But sometimes it's, sometimes we don't have to cycle through too many, and we still want to explore the data interactively. This is also something I can show on the last day about the interactivity of the data. And now, just for the sake of testing, if the switch is switched to 1, we shouldn't see anything on the screen. We shouldn't see any window. Let me just close all the windows and clear all the disk space, the workspace. And now I press play. And I shouldn't see anything here. This interactive plot on. So now it's writing, cycling through the 12 files. Okay, now it's done. So in where I have all the data, just double checking that the time, yes, the time of the files, the timestamp has changed. So yes, this is, we just created this image and they're the same that we saw there. Okay, so I think this closes the, this was the end of the lecture part. What you need to conditional blocks, and they're useful and they're used a lot. There are other types of conditional blocks that we will check later today, but I don't want to spoil. Could have a break. 8:57, so we can do 10 minutes starting. So we are back at 13:07. In the meantime, we can check if there's any questions on the HackMD. So yeah, let's have a break, well, until 13:08. And for those who need the credit or the certificate or both, send me a direct message in the Zoom chat with your so that I can mark it. Thank you. And just one thing, since you might still be around and listening, even if you didn't explicitly said earlier that you want a certificate, it's fine. You can decide on the last minute that you need a certificate, and that's okay. So I'm happy to make certificates, because in some cases you might need to show to your, even though you might not need the credit, but maybe you need to show your supervisor or committee that you took part into this course. And still, I recommend to do the homeworks, because the idea is that it's 27 hours of workload. In practice, it's going to be less because I gave some discounts. But in the end, what matters is that you learn what you need to learn. But now I'm going to be silent until 13:08 so that you can rest. Okay, so it's 13:08. I remind again that if you just logged in, or that if you want to have the credit or the statement, meaning what is the certificate, send me a chat message with your name and surname so that I can log it. I can log your presence and your wish. All right, but I don't see any questions in the HackMD, and I guess there was nothing specific in the chat. Some syntax error I remember seeing. If you want to write it in the HackMD with more details, we can check that syntax error later. Zoom chat is a bit challenging. All right, so now we can click next with our software carpentry course. And for your convenience, I'm pasting the link of the next page in the chat. And now in this part 7, which will be enough time now to do, we talk about functions. So we kind of already talked about function because you understood that all these things, all these commands that we call, like here in the background, you see subplot, plot, title, they're all functions. So functions are a core part of Matlab. I'm not really going too deep into functional programming or object-oriented programming. That stuff, you can learn it somewhere else. Here we just want to be practical and kind of, the main idea or objective we have function is that, we want to have our code reused. We want to have something that if we see that there is a value in the code that we wrote and we might run it again tomorrow, in 1 month, 1 year, and maybe others want to run it again, then it's good to kind of turn it into a function. So making the code generic enough that you just specify, today we had these 12 files with this specific folder, but tomorrow we might have another number of files in a different folder. So, the function could take this kind of arguments, they're called. There are different types of inputs so that the function can be, live and be reused. So in this specific part of the want to use, basically we want to write a generic function that is something that we might need to use a lot in our work. And specifically, it's a function that wants to convert the so-called Fahrenheit way to measure the temperature into Kelvin. So it's good to look at the syntax of this function. So now I go first on the command window. You should write the function as well. And let me hide the editor a bit. All right, so normally, let's not go into the exceptions, but let's say that functions are named as the file name. It makes things easier for Matlab, it makes things easier for you. So now we have, because the function name is far to Kelvin, I'm going to create a file called far_to_Kelvin.m. So I just type this in the command and press enter. And now the editor is saying, this file doesn't exist. Do you want me to create it? Yes. All right, so let's start typing what they had there. So ktemp, I will tell what is this ktemp. Then the name of the function. You look what I did here. I started to type FAHR, and then I just pressed the tab button, and it auto-completes because Matlab knows that I'm writing a function and this script is called like that. So you're writing this function. There might be other sub-functions inside the script beyond the scope of our Matlab Basics course, but basically we're writing a function that's the same name of the script. Now this function wants to have some input parameter, ftemp, which will be this Fahrenheit, temperature in Fahrenheit. And then of course, as always, we want to write a little bit of help comment so that we remember what this does. So the convention is to rewrite the same function name, and then I press tab, and then a description convert Fahrenheit to Kelvin. Expert in this kind of stuff, but I blindly trust I'm sure this is correct. I have vague memories from high school. And end to end the function block. Right, so the function is created. I can save it. Oops, I did save it. And so now I'm not going to read through all the text, but I can summarize it for you briefly. That this is what I was saying earlier, that the function name should be stored in a .m file that is named as a function. So that makes things different, easier for Matlab and for you. So then what is interesting here, this is called the function kind of fingerprint or the function definition. It's looking at this first statement that we wrote. So the name of the function, yes, we all got it. So this is how we will call it in the future many times. And then the input parameter, now this ftemp is kind of the input parameter, and then the output parameter, what it returns. Now, so this is kind of the very basic. This function only has one input parameter and only has one output parameter. You can have a bit of combination of both. You can have functions that have 0 input parameter, or you can have functions that have multiple input parameters, and same for the output. You can have functions that don't return any output or that they return multiple outputs. Here, I'm not maybe going to write this example here, but this is just to show how it is with multiple inputs and multiple outputs. So they are separated with the comma. What is interesting is that even though this notation would be like an array, it doesn't need to be an array. Out1 can be, I don't know, a double digit like this, double precision number, and out2 can be a string. So, you know, multiple things can be, and the same goes for the input. Input 1 could be a number, and input 2 can be a string or a path to a folder, or whatever. All right, let's continue. So if you remember, a few days ago, last week, we talked about the visibility Matlab sees, that if I type, when I now switch back to the terminal window, if I type plot, Matlab is plot. So by checking where it is, I can type which, and then the function name, plot, and Matlab tells me, yes, you have a function called plot, and it's stored in this specific location. So this is the so-called path that Matlab sees. If I type path, I see for my installation all the folders that Matlab kind of searches for a function. If I type a function with a strange name, Matlab is not able to find it immediately, checks all these folders, and if in the end it doesn't find it, I don't have this function like Enrico on function, you know, there's undefined function or variable. This is a kind of common error that you get when you do a typo in a function name, you know, so Matlab is just telling me, you know, this is not defined. But our function that we have here, now there is, we created it and we store. So if I type which, and the name was far, what was the name too? One second, that might, I guess Matlab is searching. Far to Kelvin, it should say that there should be one here where I am, because the folder where you are is visible. Okay, I don't know now. Maybe there was another Fahrenheit to Kelvin. Now it looks like that Matlab is starting Simulink, which we don't really need, and we didn't even cover. Okay, maybe it was just for checking. But basically, yeah, no, there's just this Fahrenheit to Kelvin, and it's stored in the folder where I am right now. Excellent. So now we can actually start using this function. So let's start converting. So 32 Fahrenheit is the 0 Celsius, so it's the 273.15 Kelvin. So let's check that things are working as they should. And I'm gonna type my function that I just created to Kelvin with the input value of 32. Yes, I get the number. Now it's stored in this answer, but I could store it somewhere else, on a variable x. So now x as the output, Now, if this function would return, now I'm not really reading what is written here, but I tell you already that if this function would return more than one parameter, I would then, if I write it like this, I would be happy to just get the first parameter. But if I would need to get two parameters, I should write it like that. It's just that the function that we wrote here right now, it's not returning two parameters. So now this should complain and say, look, you have too many. You're asking for too many output parameters, but I can only give you one. And yes, two output arguments. This function only returns one. But then other function, let's say the correlation. Well, maybe let's check this in the more advanced lecture. Let's not deviate too much from the teaching material, but basically this is if you would have more than one output, both, you would start needing all the outputs that you want to get. And you don't need to get them all. You can get as much as you want from your specific function. All right, what is interesting and what you might know from other programming languages is that the scope or visibility of the variables in the function stays in the function. So let me go back to the editor. What it basically means is that this ftemp here, it's not a variable in our workspace. So if I go back, now I'm covering the teaching material and go back to the terminal. If I check my workspace, maybe let's clear the workspace a bit. Clear all and close all if we had many images open from before. I'm gonna rerun this x equal Fahrenheit to Kelvin, and x is that value. If I check my workspace, there's just x, there's just the output that I defined. So all these other variables, ftemp and ktemp, they were just leaving, they existed only within the scope. And Matlab created a separate interface where now we have a variable ftemp and ktemp doing multiple things, and then when it's over, it go back to the kind of master original main workspace, and in this case store the output to x. So even if here inside I would have a statement like x equal to 15, the function, it's not like x outside the function. Let's go even in a different way. Well, no, maybe let's see it like this. If I would now run this function again, x is still equal to 2273. This other x that is inside the function is a different x. It lives in a different workspace, in an independent workspace. And honestly, this is the best way of working with variables. There are programming languages, and also Matlab would allow the definition of some constants, some variables that are the same in all these workspaces, in the main workspace as well in the function workspaces. But I personally prefer to make clear or to make sure that whatever happens in the function workspace stays in the function workspace, and the only values that will get out of this workspace are the ones that are specified here, specifically ktemp. All right, so let's go back to the teaching material, maybe brief. There's not this, but basically here I didn't read what it's written here, but this is kind of the visibility of the variables. Now that we're seeing how to convert Fahrenheit to Kelvin, of course, we also wanna maybe, convert from Kelvin to Celsius. So we need another function that will be called Kelvin to Celsius. So I do exactly the same, and you can do the same. So I'm going to type edit, name of the function .m, and then press enter, and the editor pops up and says, do you want to create this file? Yes, please. Move the editor a bit so we can check the teaching material. And then I write function. Now the output value is C temp, so the temperature in Celsius. The name of the function, I start typing kel, but then I press tab because Matlab is clever enough to finish everything for me. And the input is variable name is K temp. Okay, then some help for future users, Kelvin to Celsius, convert from Kelvin to Celsius. There's a typo here. All right, and the formula is pretty straightforward. If you remember these things from high school or wherever you've been seeing this stuff in your life, and that's it. All right, so I can save it. I now use the shortcut for saving, which is Command S or Control S. It depends on your operating system. Now I can go back to the command line and then test this function. So if I type Kelvin, I started to type Kelv and then I press tab. Matlab sees the function in my work folder, and so it can complete it for me. And then we want to test it with the value 0.0. So now we should return this minus 200. Then it works. 273.50. All right, and now we can, of course, kind of the bridge, the bit that we miss in this triangle of formats of storing temperature is it's a function that would convert Fahrenheit to Celsius, for example. And Fahrenheit to Celsius can be, we can actually kind of, nest the two function or call the two function one after the other. That first we can convert the Fahrenheit to Kelvin and then the Kelvin to Celsius. So we can basically, when I started, then I mentioned the idea of reusing your code. We can actually now reuse what we already written somewhere else and make just a kind of a wrapper, as they call it, something that, doesn't need to, you don't need to retest that the formulas are right, typo in the Kelvin constant. Just combine functions that are written somewhere else to get your new function. So now I'm gonna do it, and you should do it as well. So .m, yes please. So function, the output is the temp, it's Celsius. I start typing, then now look, I started to type a bit. There was already another one that was Fahrenheit to Kelvin. Matlab is also giving me that option. Do you want to use Fahrenheit to Kelvin, or do you want to continue with the one that you defined in the file name? And I just press enter because I'm happy with the first option. And then the input variable is f temp. Okay, a bit of help for future R to Celsius, and then convert to Celsius. All right, so now basically if the f temp is the value of input, so we want to do two steps. First we create k temp. So first we go from Fahrenheit to Kelvin. Look that now I press the tab to finish the writing because we already have the function written, and that was f temp, and then c temp equal, we have this Kelvin to Celsius. Yes, k temp. Okay, temp is the last value that is returned. Okay, terminal down a bit, and now we can test it. We can call then this to Celsius, passing the 32 Fahrenheit, which is equal to the 0 Celsius, and that's correct. So this is our first taste of how larger programs are built. We define basic operations that can be reused into, larger chunks, so that we don't need we don't need to rewrite every time these single formulas or the single bits. We can reuse them, and Matlab itself comes with many of these functions, that they can be reused. All right, so maybe let's not spend all the time, I think, in the maybe I stay silent for a minute, that you can start. We read it together, you can start think of it together, but then we can code it together. So in Matlab, we concatenate strings by putting them into an array. So like we've been using this, and basically this combines all the strings. All right. And now we want to have a function that would basically write a function called that has two parameters, original and wrapper, and adds wrap before origin. So before and after origin. So basically, there's an example here. We want to write a function that it takes two parameters, and the second parameter is put around the first parameter. And it's for strings. So it's using the disp, and it wants to generate this output. So I'm going to be silent for a minute, if you can think of the exercise, and then we can try to solve it together. So if you don't want to spy on the solution, you basically need to write a function like we did for this Fahrenheit to Celsius, but now it takes two parameters. And as you see, this function doesn't really have any output parameters. Well, no, actually I'm wrong, because the output is not stored, but the output is passed. So it has an output parameters. I can mention later how it could be without output parameters. I can check the HackMD in the meantime. I would say that, so this is a good question, HackMD. Maybe if you're trying to do the exercise, I answer to it in written, and then we can talk about it later. Okay, if you now want to use the zoom buttons, you find them if you click on participants. Let me quickly reset. You can basically mark yes if you were do this. Create a function that concatenated. If you can press yes, I'm expecting some 51% of yes. So far, 2 people pressed the button. In the meantime, we can spy at the solution. It's actually quite fast solution, meaning that so now Matlab has used this command, which is the str cut. So the solution here was using this string concatenation, but a good solution would have also been to do it like this with this wrapping. Of course, this is something that we will see in the next hour. You can already see that we are assuming that these are strings. We're not really testing if we're passing strings or if we're passing whatever we're passing, but it's a simple function and it will basically return the original string with this second string wrapped around. There is one interesting point in the HackMD that they ask, is it best practice per file? I think that it makes things easier to fix and to read. In object-oriented programming, you might not now go into the details, but you might have that in the same definition of a class, and that's why you have a user with all the methods. They're kind of like the functions that we're working here. But here, if I know that something is broken and the bit that is broken is whatever function, I can just go to that, open that file, read that function, and hopefully easily fix it. So for example, I wrote here in the command window which mean, so where is the function, and gives me this very long path. And let's explore. I'm going to use the terminal for simplicity, but it's called, I don't see the name here. Data fun, so data function. And you see here there are all these functions from Matlab, like covariance and cumulative product, cumulative sum, deconvolution. So here, all these mathematical data analysis function, they're all into one folder, the FFT, two-dimensional FFT, inverse FFT, there's so many of them and each lives in its own, So we've been using, for example, mean, the arithmetic average. I can get a preview and here, we see something like we saw here, something like we've been writing, the output value is just 1, and here are all the types of parameters. Sometimes we're happy to just pass one parameter, or sometimes we want to pass them more. And here we don't need to, what is nice with Matlab and even more with Python is that you can actually open this. Not all the Matlab function you can open because some are built in. This is a case where you can actually open it and see and kind of learn. It's not easy to kind of follow, but at least you can learn by reading. It's interesting here that within the main function there are sub functions, like I mentioned earlier. So there are some kind of helper functions that most likely these functions are called from the top part of this mean. And so here we have helper functions that can be reused. Let's go back to the teaching materials now. Well, this is another function. The exercise would be to create a function that returns the first and the last letters of a string. which basically means that if the string that is passed is S, we want to return S1 and S end, if you remember from last week. So if we check the solution, it's similar. It's a one line. Here, of course, we are assuming that S is a string, and we are not really, if one would write a program, we need to test. We will see later at the end about testing. But here, we assume that we know that S and things should go well and return this output variable. So this, it's worth doing it to Matlab prompt. Okay, so now they are asking us in this exercise, think again of that Fahrenheit to Kelvin function. This is the one that we have there. And then what does the following code displays when run and why? So here is what I mentioned earlier. Here they are setting in this workspace ftemp equal to 0 and ktemp equal to 0. And somebody like this ftemp basically not in the space of the function. So if we set these two values to 0 and then we call this function 3 times, in the end ktemp is not going to take the ktemp temporary variable that was having inside the function workspace. It will still return the original 1 0. So I'm gonna now copy paste. If you can also copy paste because you should already have this function, and see what I exactly said, that ktemp at the end is still 0. So here is the first statement, ftemp equals to 0, ktemp equals to 0. Then we call the function 3 times with 3 different values. But because the ktemp of the function is not visible from this current workspace, what it is to 0. And here it's basically what we just said. All right, so the main idea of functions is that we can reuse them, or you find functions on the internet that you can reuse on GitHub, on toolboxes, etc. So now it's a little bit more interesting function. So here they're saying, let's write a function to center a data set around a particular value. So here they got some data, and then they wanna, do a little bit more fun than what was doing earlier, converting Celsius to Kelvin, and it's actually some, data analysis. So let's define this function here, edit center temp. Yes. I don't like that they forgot the, in a way, what we're doing here is kind of center the data into a new mean. Global mean data. So the thing, so data could be a vector or a row or a matrix. Doesn't matter, because when we do it like this, the reshaped into a single column vector, and the mean will just compute the mean of everything. And so this mean of everything is then removed from the data, so like the whole data, all the values of data kind of, so that their mean is 0. And then we add the new mean, which in this case is desired. All right, I'm gonna save it. And now we can test it like they mention here. So the first line for this test is to define a matrix full of zeros. Matlab has a handy functions for this. So here is defining a 2 times 2 matrix containing all zeros. let's check intercept set, and yes, there was 0. And now I want to call our function. You can try the same and center the function so that the new mean of all these values can be, for example, 3, like they are there. And now, yes, it works. The mean has been shifted. It can be, if there's some time and if there's some interest, I can talk about random numbers on Thursday. Generating basic tricks containing Gaussian distributed random numbers, which means that it's a 2 times 2 matrix of random number. Now let's check set. Okay, let's check what is the mean or the global mean of these numbers is 0.2. But you know, often with random numbers, we would like them that they are random enough that, for example, that the mean is 0. Often, you know, the Gaussian distribution is 0 mean and variance equal to 1. So we could, for example, run center so that our random number matrix has a desired mean of 0. So we can we're just basically removing the mean. And so we shift all our numbers a little bit lower. So then instead of having a mean of 0.2, we have an actual mean of 0. So this is quite a useful function. It's a similar function called z-score in Matlab, but I talk about that right now. But basically, we in this teaching material, we are introducing this center function because it's one of those data processes that we were doing with our data. So basically, once again, we can how can I say, recenter the original data so that, for example, with we recenter everything into the 0, like I just said right now. So let's try these commands, and you can try them as well. Data, I use the load because my Matlab version doesn't have read matrix. Data / inflammation 01 CSV. So now I load it, and then I call it centered equals center of data. And now we want to center it around the mean. Now let's check the workspace. We have center and we have data. Look already that, you know, this is a bit of a side effect of the way of, because once we pass this type of, how can I say, once we pass this type of input, we are passing like a vector. So now center doesn't know anymore about the size of the matrix. But for our purpose, that's okay because we're still looking at these global numbers. So now, if this would be the so-called summary statistics for the data that was not pre-processed, and now I paste it here. Global mean was, and the global max 20. Now with the new that we have, now we have that the global minimum is -6 something, the global maximum is 13, and the mean is, you know, it's not exactly 0, but it's close enough to 0. So it's interesting to, you know, I don't think here in the teaching material they really, they really mention is basically what happened is that this kind of operations, you know, there's always some, how can I call it, mathematical error, because the numbers that we store in memory, they always have a finite precision. And specifically with scales of the numbers, the finite precision is around 10 to the -15. This actually has a special name in Matlab. It's called epsilon, EPS. And if you type EPS, so this is kind of the minimum precision that you can work in this, you know, using this type of range. Of course, you can do math operations at the, you know, with really tiny numbers, but basically, you know, it's just a shift of the exponent. But anyway, the idea that I'm saying here is that this mean of center doesn't return. It's not exactly 0 because of the limitations that we have, but it's kind of close enough to 0. Here in the teaching material, they show, for example, the standard deviation of data compared to the standard deviation of center. In theory, it should be equal exactly to 0. In practice, so we don't get exactly the same value. They get kind of, this here. What they say here, the difference is very small. It's still possible that our function is wrong, but it seems unlikely enough. All right. So then here they basically did what I was doing, that it's good to write some documentation on the function itself. So I think I already did it in the example. Yes, I wrote something. And I like to write it like this, but of course, and then you can write more. Returns an array containing the values. All right. So now that we wrote this help, when we go back to the main command, main terminal command line, if we type help of the function that we wrote, Matlab basically displays in a nice way this, this basically help section, so that our future self or our colleagues can reuse this data, can reuse this function, without opening, without kind of trusting us that the function is doing what it's supposed to do. All right, so let me check how much we still have. I wonder if it's better to have the break now and have a little bit. Well, maybe let's do the first exercise list that we can. So in this exercise, we need to write a function that is called normalize. So this function takes an array as an input, similar to the center one, and returns an array of the same shape. So basically what we did with the center. But its value should be scale so that they are in the range 0.0, 1.0. Which basically would mean that, well, I don't want, maybe this is a nice, how can I say, exercise to write this type of function. So maybe, what if we spend now, let's not have a break yet. Let's do like this, that you can spend now 3 minutes to try to write this function. Basically try to do this exercise on your own until 13:55, and then we start a break and we come back at 14:05. So it's like a longer break, but you have some 5 minutes to think. You can of course check the solution, but this is a nice example that I've been coding myself, this type of normalization, that I want to have the data between 0 and 1. So although maybe not all of you will need to do this in your cases, in your data, but it's a nice exercise of a real case. So let's spend 5 minutes and then let's have a break immediately after it. I'm gonna be silent so that you can take your time, and we come back here at 14:05. I can grab it in the HackMD if I find it. Sorry. And last reminder, if you need credit of the certificate and you didn't send me your name, you can still, if you did send me your name, you don't have to send it again. But if you didn't write your name on a chat message to me, so that I can mark your presence. So we are back at 1407. And yes, we were doing this exercise called testing a function. Check if I can. And of course, if you have questions, HackMD is there waiting for you. All right, I'm going to be silent now so that you can focus, and then Okay, hopefully you had a bit of time to test the exercise and stretch your legs. I don't see any questions in HackMD or comments, or you also can switch on your microphone if you want. Just remember that we are recording. So basically here the task for this exercise that maybe some of you, if you actually manage to complete it or start it, you can click the yes button into the usual Zoom buttons just to get an idea, if I'm going too fast or too slow. And of course, we're all different, and no pressure if you were not able to start it or to. But basically, the function that we want to build right now, it's similar to the center function that we already built. But now, if the center one was kind of shifting the values so that the mean goes into this desired value, now what we're trying to basically do here now is to kind of scale the range so that the kind of the range, assuming that our data doesn't contain infinites, because then it gets a bit challenging. But if assuming that our data is finite values, we want that the range of the input will be limited between 0 and 1.0. So all right, I'm gonna now do it my own way, because I personally, whatever, but I still find it confusing to now start thinking, yes, v minus l divided by this. I'm gonna do it in a more clear way. So the function should be called normalize. So I'm gonna edit a file called normalize.m, and we switch to the editor. And so the function should return the output. Maybe let's do it similar like the center. Okay, to just call it out equal norm. There's many norm in Matlab. So now I started to type norm, but Matlab has many norm functions. So I guess this time I need to be lazy and type the whole. And the input, I'm trying to do it like we did for the center. It's just called data. Bit of manual documentation, normalize. Make input data into the range 0, 1. Bit of too short documentation, but I guess that's okay for our purpose. So basically, what I would personally need to do is that the first step that I need to do is that I need to find the minimum value of the data. They want to call it L as the lowest, and I need that. Okay. So it's once again the global mean. So now data might have a different shape, rows and vectors. I don't care. Here, I just forget about the shape of data and just take the minimum across all the values. And now the first thing that I want to do is basically make sure that the minimum is 0, So I'm going to make this variable called temp data equals my data. So let's say that the minimum would be 5. So then my data would be in a range 5 to, I don't know, 100. So I would need to remove this 5. So I would need to redo minus L. So now temp data is between 0 and some high value. And now the new high value that I want to normalize is this maximum of this shifted data that we have. So now I know that my output will be temp data divided by the maximum. So this is once again the compromise between performance and readability. Of course, maybe all of you here are good mathematicians and it's easy for you and it makes sense for you to read the formula, and this could have been written in a single formula. But for me, I prefer extra steps and even extra memory, because now I'm creating a copy of the data in sake of readability. So now this is very easy for me that this L is the minimum of the data, and this temp data is clearly shifted, from 0 to whatever will be the new big number. And then age is not the maximum data anymore. So in my solution here, I did some extra step. I was inefficient with the memory, but it's quite easy to read. I can follow it step by step. I know what happens, and it's, I don't need to start writing down mathematical formulas. Of course, this is a trivial examples, and it kind of leaves the time that it takes. But my point here, beyond this example, the specifics of this example, is that I prefer more readable code, which is clear what happens, rather than, now the formula is an easy one, but it could be a long combination of operators, and you might just get lost in the operators in the variable. You forget, a bracket, and now instead of dividing by age minus L, you divide just by age. This kind of errors. Now here, by breaking it in multiple steps, I made the code more readable, basically. So yeah, this is all I wanted to comment on this example. If we check the solution, at least 3 of you have marked the green button yes, so you were able to do it. But basically here, the solution that they have requires this formula. But let's check the second part that they did here. I'm not gonna spend too much time here, but maybe we should at least test this bit of code. Is they're basically telling kind of, how can I say it, this function. Of course, it's a bit of a silly test. They're just saying that, okay, take a variable a that linearly, changes. So let's have a look at what is this Linspace function. That is the first time that we see. So if I type it here in the command line, so Linspace, now you see we got 100 values. So it's good to type help Linspace, and this function Linspace generates a row vector of 100 values that goes from the first input. Basically, in this case, it would be 100 numbers, goes from 1 to 10. And then the idea here would be, that we normalize this vector, so that instead of having a vector that goes from 1 to 10, it would be a vector that goes from 0 to 1. So now here we generate a vector, then we test our function, and now we want to check, for example, that the mean of norm A is 0 and the max of norm A is 1. Yes, our function works. So a bit of a, this is just a way of testing that, that what we define here, it's that our function works. But we will talk more about testing before finishing the day. All right, now to wrap up the kind of function bit, the function chapter. So we go back to our task for this course with generating kind of an analysis pipeline so that we get all these plots for all the files that we have in the folder. And basically, so in the stage that we are right now with this plot all script that we've been incrementing and incrementing. Wait a second, I moved the wrong window. In this plot all right now, it's doing a loop, and each time, in this case 12 times, because we have 12 files, it's going to run all these types of, they're basically the same commands, replace the image, the file name, get, the data, plot the data, that they're always the same command looped into this. So here in this exercise, we can do it together. This one, you don't have to do it alone. We can actually make sure that that whatever is inside this loop can be written into a function, meaning that, we could have a function called plot dataset, which only needs to have some inputs, and specifically the file name and the so-called switch. So, do we want it that it generates interactive plots that we can immediately explore, or are we happy that, and basically what we need to do is that this new function called plot dataset would have all the bits here inside, so that then we can just call it 12 times by passing different file name. So I'm gonna now this is a good example of live coding that if you see how I do it, it's good for you to kind of how to convert a repetitive bit into a function. So what I do here is that basically at this stage, we want to call the function, plot dataset. And now we already know the input and the out and the two inputs. So one should be this file name here, and the other should be this plot switch. All right. Now everything that comes after here, you can kind of mentally think it that all the bits of code here, they're now gonna go inside this plot dataset. So I can literally select everything. I don't think there's anything. And now I'm gonna use Control X. So I'm gonna cut. Now I cut it. Let me make a new file. Now it's in my I paste it first. And now at the top, I need to turn into a function. So I'm writing function plot dataset. And the two things I need to call is the one that I left in my plot all. I go back to plot all. So this is how I'm using it. So I literally copy this bit and go back to plot dataset and paste it here. I don't think this function needs to return any parameter because it just does the plot, whether it's interactive depending on the switch and the file name that we pass. All right, so now we still miss the final end of the function block at the end. You see how Matlab, when I put the prompt here, it shows me a bit of line in the top that wouldn't be visible otherwise. And then what it's good to is to select everything and run this. Now I have to expand a bit the editor window. There are these commands to kind of auto indent, smart indent, sorry, they call it. So that when I click these, kind of things look prettier as they should be looking in a function. But you're not, I don't think it's actually, it was prettier before in my opinion, but maybe I increment the indent a bit like this. All right, we still miss a little bit of I said what's our three files, just needs the file name and switch. I can even, because we still have those, where was the plot all? Here. We still have this that I can actually be reused. I can close this extra stuff that I don't need. And then I paste a little bit here. Okay, not the best help in the planet, but it's okay. So now if if everything is fine, by running this plot all, now it's the same as it was. It's just that I moved away all the bit of code that was inside the for loop into a separate function that then one day I can run on different files, on a new path, a new data set, and I can reuse this maybe in my second paper, third paper, or whatever, how many paper I need to reuse this code. So now if I press run here, in this case, plot switch equals to 1, so it should display, let's see, work, there's a typo or something, but so far Matlab is not complaining. Will we get 12 plots? Here in the bottom, you see Matlab says busy. So it's basically loading the files, doing this stuff. Come on, Matlab, you can make it. All right, so everything was done, but I don't see any figures. So did I do something wrong? No, it's still busy. Don't understand. Something strange. I don't know why it takes so long. Oh yeah, it's me. It's not Matlab. I should have put plot switch equals to 0 if I want to see, if I wanted to see in the screen. So Matlab was writing to disk. All right, now it does what I want. So now it's interactive plots and we figures. And yes, now add figures. Yes, figure 1, etc. All right, so maybe let's go back to our exercise and see how they did it here. So it's basically a little bit better documentation for the function, but yes, they did what I also did. They cut away that bit of code into the function, and then here in this automation, what is left in the plot hole, it just needs to call this file name. All right, and they left out this data bit. In a way, it's more elegant how they did it, because right now, basically this part is hard coded into the function. So let's check my function. I tell you why their version is better, because in my function plot dataset, I left something here that is the name of the folder. And even in a way, even the subfolders, maybe this should change, So this shouldn't live inside the function, because now the function assumes that there is always a data folder and that there is always a result subfolder, So maybe one should define, that this input folder can be whatever we will have one day, and even the output folder maybe could be specified in this data set, in this plot data set. So it's not the best reusable piece of code that we could write here. The solution that they wrote is a little bit better than my solution. So basically I can fix my solution by taking this line out, putting it here. This is what they did as well, right? Yeah. But yeah, you get the idea that we want to remove as much as possible that is kind of hard, so-called hard-coded, so something that is dependent on the specific data set or day that we're running things out of the function, so that the function is as reusable as possible. Now, the best to finish this function bit, what is important is that functions make code easier to reuse and easier to understand. Last Thursday, I gave a lecture on how to make your code reusable. So although it's a bit beyond the topic here, I can share with you the lectures already on YouTube. So if you go to this research data management web pages under aalto.fi, and then RDM training, I can paste this link on the chat for your convenience. If I find the chat. Yes. So coming. Yeah, so in this web page, if you scroll down a bit and you see the session on the 12th of November, sorry, last week. This is my how to make your code reusable. That's the recording here on YouTube, so you can hear my voice again, talking about kind of, it starts from what I explained here about the function, but of course the whole picture is a bit more complex. I wrote a post that kind of, so there's no slides, but there is this kind of collection of resources that you can use yourself. I can also paste it on the chat for your convenience. And the idea of this post is that, you know, remaking a bit of code reusable like we did here is just a little part of a much more difficult task of remaking your whole analysis reproducible, applicable. So here in this teaching material, I kind of introduce concepts of reproducibility and replicability, which are a huge issue in science right now. We can easily say that more than 50% of published articles are irreplicable. So they were just lucky, and there is no way that they can be replicated. 50% is actually quite optimistic. Kind of that 50% of the published articles are false. And here there's many solutions to make your code reproducible, your software, your hardware even replicable, reproducible, and generalizable. But all right, so kind of this wraps up the course. There is still one final chapter, which is the so-called defensive programming. This now goes a little bit beyond the basics of MATLAB. This is more kind of software engineering. It's a good section. I don't think I'm going to spend the full 30 minutes as they recommend here, because the concept is good to understand the concept and how to implement it, but we don't need to go deeply. There's lots of text basically on this page. But before closing this software carpentry course, so yeah, sorry about that. I guess that's the problem of having to editing two scripts. Maybe the good side, I can answer this comment. Maybe what is good is that there is going to be a video online. So eventually, you know, but in general, like if I could visualize it, is that what was existing inside the plot all now moved into this new plot dataset, so that we didn't to write new code. We just, you know, we just copied everything that was here, everything that was here under went into the function. So basically, this is the only thing that we need to remember, that once we have a block, you know, here there was a big block where you see my mouse here going up and down, but the big block kind of, you know, got wrapped and put inside into a single function that is reusable. So this is all you need to remember of this. And sorry about the switching between multiple screens. But basically, so now it's a good moment for a short reflection. So if you have more questions and comments, you can write them here. And in general, feedback for the day. So as always, it's good that you give some feedback for the next lecture, but also for future generation. Write something good and something that could be proved about today's lecture. I forgot about last Wednesday to ask about the daily feedback, but that's okay. At least on Tuesday, things were quite good, except a bit of a speed. So if you could all spend, you know, 1 minute, couple of minutes, and just write down what was good, be improved. The good thing is that we still have one lecture, so if there's something that was not clear, moving of a looped code into a function, we can go how can I say, through the material again next time. So the future generation is also feedback for that we can take into account on Thursday if there's something that wasn't clear. And or questions or comments, anything that can be improved. So I let you all write. For your convenience, I repaste the HackMD on the Zoom chat. And it's important that now there's at least 2 people are writing something, which is very valuable. So there's 18, 16 people in this Zoom room, at least. You know, if everyone just write, it's fine. So assuming that lack of data means everything is fine. I'm assuming that lack of data means you're all completely lost, that you can't even find this HackMD and how to write on HackMD. So at least there are 4 people out of 16 who have written something about. I can already comment that it's true that the third day, this is also something that I noticed last year, it's quite packed with content, and you know, maybe this year it's good, paradoxically good, that we're all locked at home because we can rewatch the videos slowly. But last year some people were basically falling behind, that you know, there's many concepts that we are putting together, and even though I'm trying to explain them simple, but still, you know, might need some reflection. I think in general the point is for you to get an overview of these things, and it's nice that if you can try them and follow me live, but then you will learn Matlab by maybe taking real challenges and trying to then build your functions, or at least read someone else's code and build on top of it. So 2, 3, kind of 4 or 5 maybe comments. So please express your opinion in the HackMD. I leave the link there, and I leave the link open. And I'm trying to, there's already one video online actually. Somebody's asking where will the video be online, and I want to cut, there's a bit of black border around, so I can already paste where the video is going to be. It's this, well, maybe I'm going to email in your mailbox and it's saved for the future. All right, you are free to put as much comments as you want in the Hack. It's still there in the chat. Now we cover the last 20 minutes of defensive programming. There's not much to code and learn here, but kind of you already felt this while I was teaching these functions, that often the issue with the coding is that the code just doesn't do what you want to do. And maybe there's a trivial, nothing is trivial. Maybe there's that, you know, a formula was wrong or something, and that, but sometimes the formula looks right and everything looks fine, but then what is not checked often is kind of the input, that sometimes we think that the input, the kind of the parameters or the input data, kind of that everything that we pass to the code, we think that it's kind of fits within a range or within a, you know, set of parameters that we think they should work, but then they actually not work. So in software engineering, there's this concept of defensive programming, also called kind of test-driven development, where the idea is that as soon as you write some code, like a function that is supposed to do, whatever mathematical operation you need to do, you immediately, example, kind of verify that the input of that function fits that you expect. Say is some trigonometric function that should get an input between, I don't know, 0 and 1 or whatever. You can't start passing. Or if the user, let's say, plot switch in our function here. Now we don't really check if somebody might set plot switch to -1. What happens then? Like it's unclear. So we need to kind of limit the scope. Like it's like saying that the future user, which can also be your future self of the function of your code, might do mistakes, and we want to prevent those mistakes by adding tests. So basically, long story short, there's a lot of text here to read and nice external links on this defensive programming. But basically, what you need to remember is this assert. This is the Matlab function that basically kind of checks that the condition is verified, and if it's not verified, it throws an error and it stops the script. This is not just for functions. I've been saying functions right now, but of course this can also be for a normal script. So let's code this little example here. I go first to the command line. You can code it if you want, but that's no. And let's call it edit as first. I'm gonna start clear all, and close all. So we have a vector of numbers. 1, 5, 2, 0.7, minus 0.001, and 4.4. And equals to 0. So the goal here is to we want to sum all the numbers that we have here, but we should have only positive values. If by whatever reason our data, in this case this numbers vector, would have something negative, stop everything. We should throw an error and stop the code, because you know that you collected data that there's no way that should have something negative. So if these things happen, you want to stop the code. All right, so let's check this. I press play, and now it's testing this assert, and here it's failed. So it means that it's really failed. So it's the point where it was. So now the cycles are going. It starts with the first number. Let's put some. It's easier to follow the math. It starts with the first numbers. It starts with 1. Everything is fine. It continues with the 2 and sums it to total, continues with the 7. But then it reaches a negative number and it stops. So I'm going to run it again with this easier number, and the assertion stops. We have the equal 10, which is 7, but then it stops here. So this bit of code is never run, because this is like saying, this is the way of saying if something, if this is not true, then the program stop everything. And so basically having this type of assert statements would make sure that as they say here, a precondition is verified, like in this case should be all positive, or also post condition that, for example, we need to make sure that output is in a specific range, or that here they write that the function is true when it finishes, So if we do all the math, our output, let's say, should be a positive number, and that is not true, then we can throw an error even on the output and say, stop, there is something wrong. Why do we get a negative sum? And then another thing that is often tested is this invariant. So kind of, that within the code, something should stay true. Might not be related to the input or the output, but to some intermediate step. So now here, as I said earlier, this kind of goes a bit, it's more about software engineering. When I started coding about Matlab, I wasn't really testing for my inputs and for the outputs. So this starts more going towards the fact kind of good coding practices. So it's not just about Matlab. You will start coding, and you just want to start doing in a good way, especially if you start going beyond the simple cases of having one specific data that you know really well, one specific set of processing and an output. When you start writing, for example, functions, as they say here, functions are, it's where you really want to test for this, because if this wouldn't be a function, you would use it today and that kind of the inputs are right, but you don't know in 1 month how you will use this function, and you don't know maybe how somebody else will pass to this function. So then assertive code is usually kind of comes the function. It's basically the so-called input validation of the function to make sure that here we're not passing, I don't know, a string, or we're not passing something completely different. We need to pass, for example, here the assert statement, in this example here, we don't need to go through the details, but then we need to pass a rectangle. So kind of 4 values to define the top and bottom corner of the rectangle. And already there, if we're not passing 4 values, that's it. Yeah, we have to kill the function. We have to exit the function because already the first requirement is broken. So that the length of the input parameter is 4. One could add here, to make sure that this is not a string, because I could pass a string of length 4, and this would leave. This would survive the, it is a test length 4, but then here things would start maybe breaking or maybe behaving in a way that we can't even predict. I don't know what would be the comparison between 2 strings, A lower than B. Maybe it's a true statement, I don't know. But point being that when you know that things should follow kind of how you designed it, how it's expected to do, then you add this assert statement, which, as I said earlier, it's like having an if statement, that if this condition is broken, so if this is false, then stop everything and output and produce an error. So in this case, you would see on the screen invalid x coordinates. So I don't think I wouldn't spend too much time on learning to code like this, but this is something that it's good to be aware. So you are aware that this exists, and you are aware that when you start writing you want to test for these parameters. So I would basically spend the last 10 minutes to kind of in the slides I mentioned about working with other people's code. What are the slides? So that working with others' code. So most working with other people's code, and it starts to get tricky when working with other code, because sometimes kind of goes to this idea what I was briefly mentioning earlier about kind of the reproducibility and replicability. So when somebody's code, things might start breaking for multiple reasons. in general, there is no course on what is the best way of working with that code. My suggestion is to kind of not be scared to go inside the code and start testing it. So that, imagine that you inherit from a postdoc in your group this kind of, script here, like we did here, that does all the plot. And then, you're not sure what happens inside here. So basically with this debugger, as we saw in was it in the first or in the second lecture, you can start checking all the files that get called, the flow, and what happens inside the code. What I find also useful is that sometimes, so now there is a function plot dataset, which is a function that maybe this person has passed to you, and you're able to open it and see it. But sometimes, somebody might call a Matlab function that you never see. So it's very useful with the Matlab editor to do right click on top of the function name, and then you can actually open it. So you see, I can click on open plot dataset. This is a simple case because I already open here, but imagine that I have something like this. I'm inventing now, subplot 2, 2, 1. And I don't know, maybe it's the first time that I see this subplot and I'm not sure what it does. I can right click and open subplot or help on subplot. So that has been given to me with this extra, how can I call them, extra enhancement that I can understand what's going on. So maybe here I'm not, this is some obscure function. Let's say set score that I mentioned earlier, and some data here, random data, 100 random values. So maybe this time they use that score and you have no idea, then help on set score. And then this is the equivalent of typing this doc. So now we get, basically Matlab opens the set score function. And then you understand, all right, so this person is basically applying the set scoring, so removing the mean and removing the variance and storing it in the output. So it's a big effort working with other people's code. In the ideal world, you would be able to read what it says on top of here and you know what's going on. Maybe you just change these things in the top and you forget about the rest and get what you want. But sometimes, and very often, our colleagues or other scientists who give their code to you, they might be obscure with the documentation. They might forget to add new features here. So there is no other way than opening the code, and whether you want to go through step by step or interactively with the editor to, basically check, you can even check of this set score. So I right click here and I click on open set score, and it is all the stuff here. So it's this is the best way to kind of work with other people's code. Then another that maybe those of you who are familiar with other languages, you already know about Stack Overflow, but Google and Stack Overflow are, your best friends. Matlab also has its own Stack Overflow. So you don't just need to go to the normal Stack Overflow, but kind of there is this Matlab, what's the name? I never forget, I don't remember. Yes, so Matlab Central, yes, sorry. So this is an amazing resource that often you are stuck because you didn't write the code, or maybe you don't know what to expect. So it's enough to start looking for an error, and you get hopefully somebody who had the same error, and maybe hopefully somebody from Matlab who gave a solution. This is one I'm not saying that I'm pro Matlab or pro Python. Maybe I'm pro Python than Matlab because of the openness and behind the Python project. But every company, in this case like Matlab, have paid people where they have a financial reason they are strongly motivated, financially motivated to check. Now I'm opening some recent question here, and then to basically check the questions that are coming and proposing answer. Of course, like Stack Overflow, also Matlab Central is community built, so sometimes you don't get any answer from the Matlab MathWorks employees, but you actually get answers from the people like you who had the same error and who were able to fix it. We don't really, like, maybe on Thursday, if we think of your wishes, there are many things that could be, how can I say, once you read from somebody else, there are that you could test kind of forerun or saying that you understand that code and now you can finally into it. But I would say that these minimum steps of going through the code step by step with the debugger or with the inline help, it's the best way to start. And most likely, if you are going to become a Matlab user, you will face this situation. You will have to deal with this situation. All right, been talking a lot. Give some few minutes at so that I switch off the recording and you can ask your questions if you want to switch on your microphone.